Welcome to the Stormsurf video surf forecast for the week starting Sunday, January 29th. Looking at significant wave heights for the North Pacific Ocean, we see two areas of interest. A gale north of Hawaii here, producing 24-foot seas, aimed somewhat at Hawaii, but certainly not at the U.S. West Coast. And another gale off the Kuril Islands, also producing 24, maybe 25-foot seas, aimed across the dateline, but not expected to do a whole lot. Let's get into the details. As usual, we'll start our tour off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their track. We're looking for troughs. That is a dip in the jet, just like right here. That helps create a counterclockwise flow aloft and down at the surface. That is the hallmark of low pressure, and low pressure, of course, generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, produce swell, and swell, of course, produces surf when it hits your beach. So we have one little trough here in the Gulf of Alaska, and that is supporting low pressure there. And as we saw in the previous charts, some seas in the 24, maybe 25-foot range here north of Hawaii. Then here we see really, though, the jet stream is kind of muddled. It's kind of split coming right off Japan. Over Japan, good winds, 200 knots, but they barely reach off the coast. The jet kind of splits. The northern branch kind of muddles along. The southern branch muddles along. They're not too far apart. And they kind of, you can see it almost splits again here with part of the jet heading up into Alaska, the other south, and then somehow tries to consolidate. Just not very organized and not super conducive to storm development. Let's roll this out. As we get into Monday, you see the pattern becomes even more pronounced. This area right here is pretty split, but the good thing is consolidated jet is pushing off of Japan with winds still in the 200-knot range, and that pattern continues into Tuesday. Now look at the split here. Big northern branch pushing up even north of the Bering Sea, southern branch south of Hawaii, down towards the equator. Just a complete mess here. A little bit of a backdoor trough here on Wednesday setting up off the U.S. West Coast. That should support low pressure development in this area. But notice winds are not particularly strong. Maybe good for a weather producer for California, if anything. But this is what is of most interest. So we'll see as this rolls out into Thursday. Notice the jet continues pretty consolidated, pushing over the date line by Thursday, almost to a point north of Hawaii. And we'll just roll this out further, and the beat just goes on. Look at that. We're into 200-knot winds still into Saturday night, reaching to a point north of Hawaii. A trough starting to develop here north of Hawaii. We'll see if that continues as we get into Sunday. And yes, it does. We'll just go 180 hours out, and this is looking much, much better than where we're at right now. So the thought is about a week out, whatever kind of weak and unorganized pattern we have right now should significantly improve over the North Pacific Ocean. Let's go take a look at surface level pressure and surface level winds. So here we are, surface level pressure, as expected, low pressure north of Hawaii. Look at this, a little tiny area, 35, almost 40 knot fetch, aimed south towards Hawaii off the backside of this low. Kind of unusual, but that would produce a very north-angled swell relative to Hawaii. Also notice there's just a little tiny patch of 30-knot winds here. Kind of aimed more at Baja than anything. Really nothing at California. High pressure kind of locking things down at this current point in time. And some sort of a general broad, weak, low pressure gale, if you will, with 35-knot winds pushing over the dateline. We saw there are seas there, but we'll just roll this out, and you can see that low quickly fades out. The low off California or north of Hawaii actually builds with 45-knot winds by Tuesday. Also, another system starts pushing off Japan with 40 to 45-knot winds. And here we go, better into Monday night, into Tuesday. Good fetch aimed at Hawaii here from the system off the U.S. West Coast. Good solid fetch, 50-knot winds here, aimed also at Hawaii. Hawaii seems to be the focus of everything for the moment. California last week, of course, was the focus with large swell pushing into northern California on Thursday. That was. All that is a distant memory now. Anyway, so we roll into Wednesday. The low off of California weakens a bit relative to Hawaii. They're still producing some 30-knot fetch. And the system off Japan starts heading north. Remember, we saw the jet pushing well up to the north. And so the storm track will follow what the jet stream does. That's why we take such close eye on it. Anyway, into Thursday, notice the low starting to move into California. The assumption is weather for this area, and then some sort of a broad, diffuse, low 35-knot wind pattern off Japan, but just not particularly organized. And as you see, we get into Friday, and that all sort of falls apart. The low off California starts dissipating. Then things just get kind of weak and unorganized for a little bit, but then we get into late Saturday, early Sunday, we start seeing 45-knot winds developing north of Hawaii. Remember, the jet is raging here at this time. A little bit of a trough starting to dig out in this area, so one would expect low pressure right about here. And that happens, 40-knot winds on Sunday. Another one behind that into Monday. You can see the makings of something. I mean, look at this low pressure almost filling the North Pacific Ocean, but just not real focused and organized yet. It really depends on what the jet does. A week from now, it's hard to say exactly how this is going to play out. You can't trust the models that far out. But in general, the pattern looks supportive of some sort of swell development. And of course, the thing that matters is what effect do those winds have on the ocean surface. So we take a look at the wave models. As we saw before, 24-foot seas north of Hawaii, 25-foot seas off the Kuril Islands. We'll just put this into motion. The Hawaiian system builds as we saw. Notice this, 28 to almost 30-foot seas on Monday night, and very kind of a north-northeast angle relative to Hawaii. The issue is probably going to be wind in the islands, but still a very interesting swell angle and kind of rare for Hawaii. Certain locations will probably light up as a result of this. Also, new system pushing off of North Japan, 35, 36-foot seas, building and holding in the 38, 39-foot range. Notice as we're into Tuesday, still that fetch aimed at Japan, but also notice here was that 22, maybe 24-foot seas pushing east, maybe into Southern California, down into Baja. Kind of a nice little setup there. Roll this out. Now, as we saw before, this low just kind of, becomes more of a weather producer and less of a swell producer, and the system off west of the date line kind of falls apart and lifts north. Anyway, here we go. Oh, actually, let's go back right there. 20-foot seas, again, on Wednesday night into early Thursday, aimed at Southern California. Southern California might actually get a good little pulse of 13-second westerly swell out of this system. And then as we get later in the forecast period, this system moves onshore California. The Pacific kind of just isn't real organized. Low pressure starts developing north of Hawaii. We saw that, and we get maybe 31 or 32-foot seas out of it. We actually suggest 35-foot seas, but that's a week out. Sunday, a week from now. Okay, well, maybe so. A little bit of swell for Hawaii, certainly for the U.S. West Coast. And then another system developing behind that. So it looks like perhaps a more active pattern. Certainly some odds for swell. No super consolidated, strong swell-producing systems or forecasts, but certainly not a placid sort of situation either. Surf, but nothing over the top. Let's start looking out a little bit further into the future because there's some interesting things going on. Specifically, we want to look long-term at the Madden-Julian oscillation. That's a weather oscillation that travels from west to east across the Pacific on the equator. There's an active and an inactive phase. Both of them last maybe 3 or 4 weeks. First in the active state, then oscillating to the inactive state and back and forth. The active state is responsible for helping to fuel the jet stream in winter months and helping to fuel storm development over the dateline and in the Gulf of Alaska. Our other situation is, well, it was La Nina, but in many ways, as you shall see, La Nina is nothing more than a distant memory. Let's get into the details. So first we want to look to see what's going on with the Madden-Julian oscillation, and what we're really looking for is the active state of the MJO. So we look at winds over the equator, East Pacific here, West Pacific here, New Guinea here. We see, and these arrows are winds. We're ignoring water temperatures at the moment. This is from the TAO buoy array, a string of buoys run across the equator in place to monitor the presence of El Nino or La Nina, but also good for sometimes looking for the presence of the active phase of the MJO. Currently, east winds in control, 2, even 160 east, and it's hard to say what's going on over here because, as you see, there's no data. But there is some little bit of westerly winds here to the south of the equator. And then we look down at this pane. This is anomalies, differences from normal for this time of year. Basically, a normal weather pattern across the bulk of the equatorial Pacific. And here in the Kelvin wave generation area, that is from 170, so from here over to New Guinea, about 135. 5 degrees north and south of the equator. If you see westerly anomalies or even slack anomalies in here, that suggests perhaps the active phase of the MJO, and we see a little bit of that, or at least a neutral MJO pattern. If La Nina were strongly in effect, we would expect to see a lot of east anomalies in here. We're not seeing any of that. We're seeing a very weak mixed pattern. That's actually a good sign. Next up, we look for the wind forecast in the same area, Kelvin wave generation area. So this is the wind anomalies, zonal wind anomalies, 850 millibar anomalies up at 4,200 feet. And the Kelvin wave generation area is basically between these two tick marks. And if you look down here, this is past history moving towards the current. And you can see here in early January, so the blues and purples, easterly winds or easterly wind anomalies. The reds, yellows are westerly anomalies. The Kelvin wave generation area, right in the middle of it, there was sort of this battle going on, easterly anomalies, westerly anomalies. We thought it was the result of a Rossby wave. Anyway, so we roll down. Here's the forecast. Here's current period right now, and it's still the same sort of thing going on where easterly anomalies are in half the Kelvin wave generation area, westerly anomalies in the other half, and the battle is still not won, not decided. This suggests that La Nina is probably still in play in the atmosphere, though we have data that suggests it's not the case in the ocean. But remember, so the La Nina El Nino thing, it takes months for the atmosphere to respond to changes in the ocean. We'll get into the oceanic discussion here in just a second. So it's no surprise, La Nina's been in play, and this sort of suggests that for the next week, this same kind of the MJO just isn't real obvious from the wind pattern, and it doesn't look to be having a huge influencer on what's going on down at the surface. But the MJO is not all about just winds. It also is about precipitation. So these outgoing long-wave radiation models, so the oranges and yellows suggest less precipitation than normal, which also means high pressure, which means the inactive phase of the MJO. And we believe that's where we are right now. And this goes out 2 weeks, and it suggests, and the Kelvin wave generation area is from 180 or actually 170, so draw a little box in your mind right along in here. And this suggests the inactive phase of the MJO per the statistic model is to still be in control over the next 2 weeks. Now, the dynamic model, the GEFS model, GFS ensemble model, suggests the inactive phase is to die a bit quicker than the statistic model suggests, and the active phase of the MJO, these blue colors, represent less sunlight reflectivity off the ocean surface, meaning clouds obscuring sunlight, which means the active phase of the MJO, which probably means precipitation, and that would be favorable for storm development. The active phase tends to feed the jet stream aloft, make it stronger. So this model suggests over the next 2 weeks that the jet stream would get stronger. As we saw, remember, we saw about a week out, the jet stream looking pretty good. So a week out would be somewhere around the early part of this frame here, building strong coming off Japan over the date line, and that would be attributable to the active phase of the MJO if one is to believe this model. Another way to look at the MJO phase diagram charts. So assume this circle is you're looking down on the North Pole of our planet. The MJO travels west to east or from the Indian Ocean over the maritime continent. Consider that Bali, New Guinea. Over the dateline into the West Pacific, underneath the United States, across the Atlantic, over top of Africa, and back to the Indian Ocean, making a trip the whole way around. So the big dot here is where the active phase of the MJO is. So basically it's in the Indian Ocean. If it's near this circle or inside of it, it's considered to be very weak. So this would be a very weak active phase of the MJO. Over the next 2 weeks, the track has it moving into the West Pacific, this per the ECMF model. Okay, so that's one more a bit of data that suggests the active phase is coming our way eventually over the next 2 weeks. The GEFS model, same model we were looking at before, also suggests the same thing, but it suggests that it's going to be very weak. And that has been the case with La Nina in play. It sort of stomps on the MJO and just makes it not strong and makes it kind of hard to discern where it is and what it's doing. And then there's our trusty CFS model. 850 millibar winds. Again, the same sort of chart where the Kelvin wave generation area is from basically between these two tick marks, actually offset just a hair bit to the right. Now this one, past history, is down at the bottom. The forecast is the future. The line is where we are right now, January 29th, in the Kelvin wave generation area. And there you go. You see easterly anomalies in the east half of the Kelvin wave generation area, westerly anomalies in the west half. Let's overlay the MJO. And as we see, the inactive phase of the MJO is currently where we are. It's right in the middle of the Kelvin wave generation area right now. But the good news is by February 6th or so we're talking just a week or so out, it's supposed to be moving away. The active phase of the MJO is to move in, but it is also supposed to be very weak. Notice easterly anomalies, even in the heart of the active phase in mid-February, still in play. Westerly anomalies building a little bit in the West Pacific. And then here we go with another weak inactive phase in late February into maybe early March. And then another weak active phase of the MJO by March into mid-March. But notice here, westerly anomalies are supposed to be building over the entire Kelvin wave generation area. But the model has been saying that for months. And as we get closer, it just keeps pushing it out and pushing it out. So we don't know that we would really, we don't believe anything this far out. But just in the next couple of weeks, this sort of same pattern, inactive, active, inactive, but not a whole lot of influence one way or the other. And then there's this one other model we use sometimes to sort of see what's going on. It's basically upper level precipitation potential chart, if you will, and it runs about 2 weeks ahead of normal. So 2 weeks from now, and this sort of fits with all the other models, but assume this is the current analysis, but what happens at the surface sort of lags behind what's going on up in the upper levels of the atmosphere. It suggests, so the green is the propensity for precipitation. One could assume that to be the active phase of the MJO. You can see that maybe 2 weeks out, running its course across the Pacific through late February, followed by the inactive phase, less potential for precipitation, and rolling out into March, and add 2 weeks to that, so you're into late March. So if we can get through the next week or so, the thought is the active phase of the MJO is going to come into play, and then we've got a couple of weeks, maybe 3 or 4 weeks of perhaps a stronger storm pattern. We're moving back to this chart because we forgot to show you just one thing. So we talked about inactive, active, inactive phases of the MJO, but then there's the longer wave pattern, La Nina, El Nino over top of this. So this dotted line here is, we'll just call it La Nina. Not really supportive of storm development. All the activity is here in the Indian Ocean right now. That's typical of La Nina. But the point we're trying to make here is by sometime in mid to late March, the effects of La Nina pretty much fade out. And notice here on the chart, come you get into April, it's like the El Nino pattern starts rebuilding right over top of the Kelvin wave generation area, and westerly anomalies return. Now, we already said don't believe anything this far out in the model, but there's a lot of evidence to suggest that something like this might happen and that we're moving into a more favorable pattern. So if you're not excited about things right now, and the atmosphere isn't super productive and super excited, though we had a nice good sized swell in California mid last week, and there's been nonstop surf, but not a lot of movement in the atmosphere that really makes you think all heck's going to break loose. Maybe that could change. So we've talked about the MJO. Let's talk about our longer wave oscillation, and that would be El Nino, La Nina. Right now we're in a La Nina pattern looking at actual water temperatures. We see warm water pulled up here in the West Pacific. Oh yeah, the chart here, West Pacific here, East Pacific here. We're looking at depth. Notice little X's. Those are sensors on the anchor lines of the TAO buoy array. These buoys are from 2 degrees north to 2 degrees south, strung the whole way across the Pacific on the equator. And so these little sensors here tell you what's going on in terms of the temperature profile in the Pacific Ocean. So warm water pulled up in the far West Pacific would be expected with La Nina and above normal easterly trades blowing here. Takes warm water from the East Pacific, pushes it over to the West Pacific, sort of makes a bubble there and sits there. And notice the warm water profile, by heating by the sun mainly, is very shallow in the East Pacific. That's the hallmark of La Nina. But we look at differences from normal for this time of year. If La Nina were really in effect, you'd expect to see below normal surface temperatures here or subsurface temperatures here. We do not see that. What we're seeing is basically neutral temperatures. There's the 0 degree line, slightly warmer than normal there, maybe slightly cooler here. There's one little pocket, the last little remnants of La Nina, 1 degree below normal. Everything else is pretty much normal. And here's what's even more interesting. We've been seeing this pocket of warm water here, and it's making some slow eastward progress, not much. But what NOAA is saying is that, in fact, this is a Kelvin wave. Now, it's a pretty weak Kelvin wave, and that might be a bit of a reach, but they're saying it's a Kelvin wave. Whether it will make the traverse the whole way across the Pacific, hard to say. There's not a lot of momentum behind it. Typically, it takes about 3 months before it reaches Ecuador. We don't think it's going to do it. But you know what? That's a lot better than La Nina. One would expect to see, like, earlier this year in March, April, it was 4 degree below normal anomalies over here. That's all gone, all wiped out. We look here at another version of that chart, and it kind of highlights the warm pool. We're starting to get this, and this is more typical of a El Nino-ish, or at least a normal kind of flow where you have at least a route, a little pipeline for warm water to move from the west to the east. When you get the active phase of the MJO, it can produce westerly anomalies blowing from west to east, and that takes warm water at the surface, pushes it to depth, and creates a little pool that then starts streaming off to the east, and then will advect up to the surface or erupt to the surface here and create a warm pool off of Ecuador and the Galapagos. That's the hallmark of El Nino if it's big enough and strong enough. So two different depictions of what's going on subsurface suggest there is now some sort of warm water flow pushing east. This is very good news. Upper ocean heat anomalies, upper 300 meters of the ocean, basically a variant on the same sort of chart, but you get to put it in time here. February a year ago, this is the last Kelvin wave, warm water pushing east. See, time goes down here. Warm water pushing east into the Galapagos. Kelvin wave number 6, that was the end of the 2014-2015 El Nino. La Nina came in May of 2016. Cool water, the blues are cool water taking over, but not very strong. And here we are now. You can see it. Warm water, again, redeveloping in the west, but making tracks to the east, 0 to half a degree above normal, almost reaching to the Galapagos and Ecuador, which would be over here. This, so pretty much, is the death nail to La Nina, and that's a good thing. So next we take a look at surface level anomalies, not subsurface, but just right at the surface. High-res satellite data here, and what jumps to your immediate eye is this buildup of, we'll just swing this over here just a little bit, of 2 1/4 or better degree anomalies, a huge pool. If La Nina were in effect, you'd expect to see cool water off of Peru streaming up, getting caught by the trades, cool water over the Galapagos, and heading west from there. Instead, we see what almost looks like El Nino building. Now, it's not El Nino, because El Nino, if the official monitoring region starts out here, 120 west out to 170. So this is what they call the Nino 1.2 region in here. You can have all kinds of variations on here, but if it doesn't make it over to here, it doesn't count. This is the Nino 3 and Nino 4 regions out here, and that's what really matters. But the fact that it's so warm here suggests that La Nina is all but gone at the surface. Here we go is the trend for the past 7 days. As expected, warming along here. This has been going on for 2 or 3 weeks now off of Peru, Chile, the Galapagos. And we have a couple little pockets here of cooler trending right in this area. Now, the Niño 3.4 region, the one that really matters, is right here out to here. So that box there. And that box is still kind of sort of a mixed bag. But it seems, or at least it feels like this warmth wants to push off to the west, but that's wishful thinking at this point in time. Now here's the actual sort of backed off high-res view. Sea surface temperature anomalies, differences in normal for this time of year. See all that warmth off of South America and the Galapagos. But here is the remnants, or what's left of La Nina, and it's sitting right smack in the Niño 3.4 region, 5 degrees north and south of the equator from 120 west to 170. So still La Nina's in play, but it's completely encased in warmer than normal water off here. We also saw what looks to be a Kelvin wave, warm water, flowing underneath this cool pool, trying to make its way over here to feed this building area of warm water. Where all this goes, one doesn't know, but typically, if you're going to have a real El Nino, you would expect to see a lot of warm water subsurface over here. We see a little bit, but it normally takes years for this to recharge after an El Nino, so we'll see. Still, the thought is there is a fair amount of latent heat energy built up in the oceans. I mean, kind of look here, you see, now, so there's two things going on. One, these anomaly charts, they are what they consider normal in the oceans. The oceans are changing. I mean, there's just no getting around the fact that every about 4 to 5 years, NOAA has to readjust what is considered normal in the oceans because the oceans keep getting warmer and warmer and warmer. Now, we're not talking wrath of God warm or anything, but it's, a 1/10 to 2/10 of a degree makes a significant difference on some of these charts. So, but anyway, the thought is there's a fair amount of latent heat energy still in the ocean, that the last El Nino did not completely discharge all that latent heat energy. Because remember, it was sort of a westward displaced El Nino, and so it didn't completely evacuate all the warm temperature. So maybe there's still some possibility of some sort of a weak El Nino developing. So we talked about ocean subsurface temperature profiles. We've talked about the surface profiles, but it's really what's the atmosphere doing? The atmosphere is what drives storms, right? Those storms don't occur down in the ocean. They're up in the air. So we'll try to tease out and see, again, it's sort of falling back to what's the MJO doing, and then what's the long-term prognosis. So, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers over a prolonged period of time suggest the active phase of the MJO. Here we go, 13th of January, it started negative. We'll actually go up here. You can see it was positive and pretty well positive, the daily index, through the early part of January. And now the later part, numbers have been negative. It was quite negative here in mid-January, and it tried to sort of rebound, but still is negative to this day. Not horribly negative, but it's suggestive. It suggests, this is where things are very strange. This suggests you're in the active phase of the MJO, just looking at it on the surface. But you look at the models, and everything says we're in the inactive phase. So there's sort of this disconnect that's going on, and that's been going on pretty much all winter, just because La Nina, the MJO is just very weak, and it's difficult to tease out exactly what's going on. Anyway, the 30-day average, the good news, continues to fall. It's at effectively neutral at 0.46. So this suggests neither if anything, it's a tendency towards the active phase of the MJO. And the 90-day running average, this is where you look for the presence of La Nina or El Nino. And you can just see it's kind of been just hovering around 0 as of today, 0.4 or 0.42, which means neither El Nino or La Nina. So again, kind of a neutral pattern suggested here. If we graph out the 30-day Southern Oscillation Index, you can see, now here we'll go back January 2015, downward trend, negative numbers. This was in the peak of El Nino. Negative numbers are good things. You can actually pick out the pulses of the MJO in this index. The downward pulses, like here are the active phase of the MJO. The upward pulses are the inactive phase of the MJO. Now notice here, big pulse of the MJO. If you looked at the Southern Oscillation Index, you couldn't see it. If you looked at some of the other data, look for westerly wind bursts, all that kind of stuff going on, you couldn't see it, but it showed up in the Southern Oscillation Index in October and November. Remember, there was a lot of storm production and surf in California in November, and then now here we are, just maybe a mini pulse of the active phase of the MJO, but now we're trending up just slightly. Still just kind of a mixed bag, no clear signals as of right now. And then the ESPI index, very much like the Southern Oscillation Index, but rather than measuring differences in pressure between the area north of Darwin and north of Tahiti, it's absolute rainfall. If you see negative numbers in the index, it suggests less rainfall here. Notice this corresponds pretty well to the Nino 3.4 region right here. Okay, and the current index is minus 1.2. That's suggesting less rainfall than normal in this area. Most of the rainfall is over here. Remember when we saw the chart on the long wave plot of El Nino, La Nina, it said all the activity was in the Indian Ocean. Well, this is pretty much saying that same thing. We really want to see this start to work its way up and become closer to zero. That would suggest the demise. And actually, you can see it here, right here. Less precipitation in normal. These are rainfall anomalies for the last 30 days. It lags behind. It's a 30-day running average sort of thing. So the Southern Oscillation Index is more of a real-time feedback. The expectation, this will be becoming more positive over time. And then finally, the forecast from the CFS model for the Nino 3.4 region. That region, 120 west to 170 west, 5 degrees north and south of the equator. As we saw back in early 2016, we were going from El Nino, positive surface anomalies, going to negative anomalies, but our La Nina here in the July-October 2016 timeframe never got below much more than half a degree below normal. That's a pretty weak La Nina indeed. As of 2017 January, we're considered to be completely neutral. The forecast suggests that over the next coming, as we get into April, we're going to have 0.6 degree positive anomaly and holding there and building to 0.75 in October. This model is therefore suggesting that we're moving towards an El Nino in later 2017. That seems a bit of a reach just because there's not that much warm water in the West Pacific and to transport in the form of Kelvin waves. But still, even if we're hanging down at just 2 or 3 degrees above normal, that would suggest the demise of La Nina and at least return to a neutral state, and that would bode pretty well for the fall and winter a year from now. Yes, we're talking a year from now. But still, the general trend is very positive, and it's all looking up from here. So to summarize quickly, right now, kind of not a great storm pattern setting up for the next week. A little bit of swell activity, certainly for Hawaii, and some for the U.S. West Coast. In fact, we forgot to mention this. Always interested in snow relative to California. This low-pressure system north of Hawaii. We'll just run through this real quick. As you see, rolling into Wednesday, this is all precipitation. Moving into California from, we'll say Morro Bay northward by Wednesday night. Snow building. Not a lot of snow and probably pretty high snow levels by Thursday morning into Tahoe. But snow continuing into Friday. Friday night, building pretty good, and then rain clearing out along the coast by late Friday, and snow clearing out by Saturday morning for the Sierra. But also notice a little bit of blocking high pressure, but another system building off in the wings, maybe more to follow. So, storm pattern, as we said, kind of weak relative to California for swell production. Hawaii certainly stronger. Longer term, jet stream supposed to get strong. storm pattern might be picking up across the North Pacific, and then even longer term beyond that, La Nina all but dead, certainly in the ocean, all but gone. Now, we're not going to say El Nino's coming, no, but at least a return to neutral and a much more positive pattern for the year ahead. And right now, if this La Nina that we're in, if this is the price we paid for the El Nino from 2014, 2015, pretty small price to pay because there has been surf and there certainly has been piles of snow in the Sierra. So all in all, not a bad situation. Anyway, we'll do this again next week, same time, same channel. Thanks for watching.